So, I prepared some slides. I think Nepali पनि छ होला हैन, so I'll mix some Nepali and English in between. I hope that will make it more understandable. So thanks for this opportunity. First of all, मेरो नाम चाहिँ Milson Munakami. I'm a lead cloud engineer at Harvard, and today's topic is empowering research unleashing cloud computing. So we'll know about different types of cloud and how we are using at Harvard the cloud computing setups. So I'll talk about those things. Give a second. All right, so the main agendas for today's topic is, so around 5 minutes, I'd say I'll talk about myself, about me, and then we'll talk about what is cloud computing. There are different types of cloud computing, so we'll talk about that. And then the project I'm involved in, it's called New England Research Cloud, also known as NERC. So I'll get you introduced about that and what kind of services we offer and how that setup is helping with the researchers and their different use cases. We'll talk about that around 10 minutes. And then we'll jump into the demo. So demo चाहिँ अलि लामो हुनेवाला छ. So it will be a little bit technical, but yeah, also the output will be more for the end users. So even you don't know more technical side of it, but you will see some of the outcome of those demos later on. So we have 3 demos. One is for the on-premise infrastructure as a service model. So it's called Red Hat OpenStack. So we'll see how can we use OpenStack to create virtual machines using CPU and GPU on the backend. अनि हामी एउटा LLM model पनि launch गर्छौं जसमा चाहिँ chat model हुन्छ. So if you know about all the chat GPT, Llama 2, those kind of things, so how can we use this kind of services to host those kind of large language models? And also we'll see it in a demo, like how can we put some prompt and it will generate the outcome from within the interface. त्यसपछि we'll talk about the platform as a service model in NERC. Like we have Red Hat OpenShift, which is a container platform. And we also see the CI/CD pipeline that can be integrated. हैन जसले चाहिँ हाम्रो GitHubमा कुनै कोड चेन्ज हुने बित्तिकै यसले कसरी रिफ्लेक्ट गर्छ हाम्रो output applicationमा. We'll see about that. And then there is an OpenShift AI platform. So if you know about AI, machine learning, how we can use that platform in order to host those kind of application on top of it. And हामीले चाहिँ एउटा simple application जसमा चाहिँ object detection गर्न मिल्छ त्यो हेर्छौं. So on time भयो भने we'll see also what are the other use cases. Other use cases Harvardमा अथवा अरू institutionमा कसरी we are supporting. I'll explain few of them if we still have some time. So about me, so this shows my professional career growth. So I first month 2009 I joined as a junior software engineer at Byproxy, and then I joined Brain Digit IT Solution Kathmanduमा. So I worked there and I was the lead developer engineer, lead application developer, and then I moved to US and then start my master in computer science at Boise State University, and I was doing assistantship there. So I worked there as a research assistant till 2016. And त्यही बिचमा चाहिँ मलाई University of Chicagoबाट job offer आयो. So I joined there as a software engineering, like application developer, scientific application developer. So Chicagoमा चाहिँ I joined as a scientific application developer on their HPC research computing center. त्यहाँ चाहिँ मैले 3 वर्ष त्यो काम गरेँ. Yeah, 2021 then I moved to the Open Common Consortium. This is a non-profit organization where I work as a senior solution architect, and then I moved to Harvard. So Harvard I joined as a senior cloud facilitator in the beginning, and then I recently promoted as a lead cloud engineer. So that shows my all professional career growth. And my introduction BE from computer engineering in computer engineering from Copo Engineering College, 2008, and त्यसपछि I moved to US and did my master in computer science from Boise State University. So let's now jump into the cloud computing. What do we think about cloud, right? So Escalizing, I have some input from you all. So if you can go into this, so either you can use your mobile phone cloud or QR code use garibani, so otherwise you can go to this menti.com and use this user code and just give me your response. So let's put a timer for 1 minute and see what you're gonna input there. So I need your input on this. Anyone? So what I'm asking is you can go to the browser, menti.com, and it will ask for this user code. Just enter this code, or you can use your mobile phone to scan this QR code. So this was a mitigation. What do you think about cloud, right? So just give a word or sentence or anything you think of cloud computing can be. So it's
Question is not open, responding is off.
really, I thought like I tested it. Yeah, so, oh, okay, then leave it then. Thank you. Yeah, maybe it has some time limit. Okay, no worries. So yeah, anyways, so cloud भन्ने हाम्रो दिमागमा के आउँछ भन्दाखेरि we think about the memory, RAM, storage, compute, CPU, GPU, even data centers, all those hardwares, right? Networking, those kind of things gonna come up on our mind. So I think that that's valid thought. And if you think about cloud, it's somebody else's computer, so it's not on your own laptop or desktop. So officially, how we define cloud computing is cloud computing delivers on-demand IT resources over the internet. So IT resourcesहरूमा चाहिँ अघि हामीले जति भन्यौँ, जति storage, CPU, RAM, memory, all those things come under the IT resources. So it need to be accessible through the internet. Internetबाट accessible हुनु पर्यो. अर्को चाहिँ अब we need to pay for them, those resources, right? So there is always going to be pay as you go model. So you will not be charged if you are not using those resources. So यसैलाई चाहिँ हामीले cloud computing भन्छौँ. So if you look into the cloud computing ecosystem, we're going to see different types of layers. So you can see application, platform, infrastructure, those are different layers under cloud computing. So infrastructureमा अघि हामीले जति भन्यो त्यो सबै पर्छ. Storage, different type of storage, compute, CPU, GPU, networking, all those hardware level gonna come under this. And platformमा चाहिँ database, runtime, identity management, those kind of tools gonna come under there. And application layerमा चाहिँ there are different security, monitoring, अनि billing, those kind of application layer gonna come around. So सबैलाई combine गर्दाखेरि what cloud computing core services area is going to be. These are some of those, right? So compute, अघि नै हामीले पनि अलिकता भन्यौँ कि compute भन्ने बित्तिकै हाम्रो दिमागमा CPU, GPU, memories, those kind of things going to come under. And storage, there are different type of storage available based on your workload. So एकदमै छिटो टाइपको स्टोरेज चाहिएको छ भने लोकल स्टोरेज द्याट इज नट पर्सिस्टेन्ट सो VM अथवा एनी इन्स्टेन्स डिलेट हुने बित्तिकै those storage will be gone. But if you need some more persistent storage, then you can go for block storage, object storage. If you want to do some application development on top of it, like connecting with those storage, then you can use object storage, which are more API driven. So you can integrate them in your application, right? त्यसपछि file based storage. यदि तिमीहरूसँग organization have lots of users and user label access label चाहिएको छ भने चाहिँ we're going to go for a file system. And beside that, we also going to talk about networking. So hardware matra bhayera, we need to expose them to the internet or any other networking IP addresses. So networking from there, and then databases. So you need to store some databases and MySQL, relational, non-relational databases, which are more replicated, more disaster recovered kind of setup. So they also provide that kind of services. And also security is a major concern because our cloud one, we're going to store so much data on it. So we need to think about how secure those infrastructure are, how secure those services are. So we need to always keep in mind like how secure our cloud computing services are. And there are different service tools and applications they provide to make this all core services up and running. So let's get back. Cloud computing को बारेमा धेरै डिटेलमा जानुभन्दा पहिला let's see how it begins. So we know the internet 101. So internet कसरी सुरु भयो भन्दा there is a need for sharing the resource from one point to another. So they connect it from one node to another. So there is always need for the dedicated physical server or virtual machines on the hardware level. But there is always need for sharing those hardware over the internet or some time sharing and hardware level sharing, right? So that those expensive resources can be fully utilized. The hardware एकदमै expensive. So even today, the GPU cost you can think of it's so much. So how can we fully utilize all those resources? Then comes the cloud computing. That's how the cloud computing emerges. And if you look into the current scenario, cloud is everywhere. So large enterprises are getting serious about adopting cloud. If you think about business, 90% already are on the cloud, right? So that is too much. And you can see 60% of all corporate data are already stored in cloud. And because we are moving to the cloud, so about like 57% uptime is reduced. So there is no need to maintaining all those things on your local drive or local setup. It's always up and running on the cloud somewhere. So if you look into the market size right now, and this is a prediction, you can see by the end of 2024, there's a the size of this global cloud computing will reach 680 billion. So that's going to be end of this 2024. But by the end of 2032, you see 3.5 times the increase on this. So it's going to reach up to $2.3 trillion. So it's huge market and it's getting bigger and bigger every day. And also the AI, all those machine learning things coming along, it's going to make it even bigger and better size. So if you look into the current cloud computing providers, those are vendors. So there are different options you can go up, right? So I mean, AWS, Amazon Web Services, also known as AWS. Google also has its own cloud computing setup called GCP, or Google Cloud Platform. Microsoft has Microsoft Azure. Oracle also has Oracle Cloud Infrastructure. And if you look into the right side of this diagram, you can see they have a similar kind of services on different levels. So if you're thinking of instance, instance, AWS level provide also, Azure level provide also, Google Cloud, even Oracle level provide also. But they have their own naming conventions. So AWS EC2 भन्छ, Azure virtual machines भन्छ, compute engine भन्छ from the Google Cloud side. So they have different name, but underlying services is similar. So choosing between one cloud computing providers to the another is pretty hard. So it depends upon what kind of workload you want to use, how much that's going to cost, and how much reliable they are. So you need to do those study beforehand. Okay. So the biggest cloud computing players, you can see Amazon is ruling the world. It's around 31% of market shares is held by the AWS. And that is Google Cloud, Microsoft Azure combination लगभग बराबर हुन खोज्छ. So Azure is also trying to wrap up and coming to compete with AWS, right? And if you look into this diagram, you can see those 8 bigger cloud computing providers covers 80% of the whole global cloud computing services. So this is huge. And you can see a remaining 21% is still there. So even you can see the Chinese cloud computing providers like Alibaba, Tencent, those are also emerging over time, right? And our AWS, there are different categories. They categorize different services. Under that, they have different application and different services underneath. So choosing from one to another is pretty hard, right? And हामीले अघि भन्यो cloudको core services are. So this is more about specialized services. So AR, VR related application, you can host it on the cloud. Even blockchain, you can do it. Even nowadays, they are coming with the quantum computing things. So it's going beyond what we can even imagine. So instead of setting up our own, now we can go to the AWS and ask for quantum computers. So those kind of things is coming along. And you can think robotics, storage, those other services are also categorized there. But the challenge is how you're going to know, right? There are more than 200 भन्दा पनि बढी सर्भिसेसहरू AWS ले provide गर्छ. So you cannot be like a master on the particular category. You need to learn one bit from here, another. So you need to learn so many things in learning cloud computing. So this was what is the benefit and disadvantage of cloud. So always we talk about benefits, but there are also key disadvantages पनि हुन्छ. जस्तो जब हामीले cloud computing use गर्न खोज्छौँ, they're going to have their own agreement level. It's called SLA. SLA भनेको चाहिँ service level agreement. So they always say like there is a chance of getting it down, right? So even though it's a 99.999%, but there is 0.001% chance of getting your service down. So recent news you can see because of cloud computing, some of the business services are down for some time. So it can happen. And also because of lack of support, so support we need to pay the price. So there is always a subscription we need to get the full support from the cloud computing vendors. So that's going to be another cost. And also if you think about security, एउटा breach भयो भने that's going to affect whole services that is loaded on that particular service, right? And that is another concern about the cloud computing. But saying that there are other benefits, like we already mentioned here and there. There are different benefits of having cloud computing. Now you're going to get low cost. You don't need to maintain your hardware, your storage, your software. Everything is done by the cloud computing providers. Updating of those hardware and software, because every hardware or software has a lifetime. So after lifetime, they will need to be updated or need to be upgraded. So that will be automatically done by the cloud computing providers. And also you can get unlimited amount of storage. So you can request how much you need, you're gonna get that and pay for that. अनि कम्प्युटको कुरा पनि अघि पनि गर्यो, you need GPU to do your research or GPU to do your project, you can get it. CPU, how much? You can just request that much, right? So there are basic capabilities of cloud computing. We talk about benefits. Now, these are some of the things that every cloud computing provider is going to give you. So elasticity. So if you want to scale your resource, then you can automatically do that on demand, like dynamically scaling your resource from 0 to scale whatever you like, right? So on-demand elasticity दिन्छ, scaling हुन्छ, अनि reliability को कुरा गर्नुपर्दा they are distributed across the globe. So it's not just one place. So even Asia, America, whatever region you want to host your servers or your services, you can get to that particular infrastructure regions or availability zones. So let's say near to the customer launcher. जहाँ customer छ, your resource will be near that. So it will be low latencies and also other benefits. And they also have this failover concept. So your service down हुने बित्तिकै they're gonna spin up another one. So your service will be keep up running and smoothly there, right? And backup and disaster recovery softwares and system is inbuilt within cloud computing setup. So you don't need to think about as a मेरो data हरायो भने भोलि के गर्ने भन्ने कुरा. So you can get it back from the backups they have. अनि cost efficiency को कुरा गर्नुपर्दा we talk about like you're going to pay what you're going to use, so you don't need to be get overcharged for unused resources. And they have these web interfaces, so you can just log into that and then do all the self-services. So it is on demand. Web interface हुन्छ ब्राउजरमा गयो लगइन गर्यो, then you can demand for how much resource you need. You can set up your own, customize it based on your need, and then it's up and running. Programmerहरू, developerहरूको लागि चाहिँ main what they provide is this SDK, software developer kits. Also now they have other API things. So यसले चाहिँ के फाइदा भयो भने end user को लागि मात्र भएन कि अब now cloud can be used by the programmers or developers or software engineers, right? So they can customize it using the code. So this is game changer. If you think of like cloud computing, end user ko लागि मात्र भइदिएको भए you'll have lesser impact now because they have this SDK. So this is going beyond the end users. It's going for the global community of programmers and developers. So types of cloud computing services, there are two. So we can describe based on the deployment. Cloud computing को चाहिँ चारवटा ग्रुपमा डिभाइड गर्न सकिन्छ हैन. So private cloud, all the infrastructure is managed by a single company, and it's not shared by any third-party companies. So it's self-managed kind of setup. All the hardware, all the software you need, the company gonna manage themselves. So you can think of यसलाई चाहिँ एनालोगीको रूपमा हेर्नुपर्दा you can think of having a car, right? Car अब आफ्नो भइसकेपछि you can customize it, you can change it, you can replace some of the parts as you need over time. So it is more reliable on your own comfort. So that's the analogy. And if you're thinking of the public cloud, like riding a bus, so bus service is not yours, somebody is providing you. So त्यस्तो केसमा चाहिँ के भयो, you just user, so you just use whatever destination you're going through and then just use it and leave it from there. So public cloud को कुरा गर्नुपर्दा it's managed by a single cloud provider, either AWS, GCP, those kind of cloud provider we just mentioned before. And if we manage, if we merge these two, then that becomes a hybrid cloud. And if it is not just one public cloud provider, it has multiple cloud providers, then it's called multi-cloud. So based on the service model, अगाडि चाहिँ हामीले deployment को आधारमा भन्यौं cloud computing को चारवटा group. अब चाहिँ service model को आधारमा चाहिँ there are mainly three service level models, right? So on-premise environment मा चाहिँ everything is managed by you, including application, underlying hardware, software, everything. जबकि infrastructure as a service, also known as IaaS, त्यसमा चाहिँ के हुन्छ भने you gonna manage, your company gonna manage only the application up to the middleware, and all the underlying hardware, virtualization, operating system, त्यो चाहिँ कसले गर्छ manage, cloud provider ले गरिदिन्छ. त्यस्तै platform as a service, PaaS, यसमा चाहिँ application र data चाहिँ you gonna manage or your company gonna manage. Other than that, it's gonna be managed by the cloud computing providers. So it includes all the runtime, middleware, upgrading those, all the nuance they can do. And if you're thinking of software as a service, so it's a SaaS. So using end user को लागि mainly focused. They don't care about what is underlying hardware, how it is done, how it is managed, right? So it's all managed by the cloud computing providers. And then the end user is going to be the real user of this kind of services. जबकि platform as a service चाहिँ कसको लागि हुन्छ भन्दा more focus for the developers who going to use it in regular intervals, right? You can develop some tools, test it, destroy it, again rebuild it and deploy it. Those kind of things is more focused for the developers, platform as a service. So apart from those three, तीनटा अघि हामीले भनेको as भन्दा पनि फरक चाहिँ यो function as a service, यो चाहिँ अहिले नयाँ टर्म हो हैन, जसमा चाहिँ fast यसलाई चाहिँ serverless computing भनिन्छ. So serverless computing मा चाहिँ के हुन्छ भन्दा you only manage your code. You don't think about what kind of hardware I need, what kind of resource I need. You just deploy, maintain your code or a piece of code in terms of call functions. अनि यसले चाहिँ underlying hardware requirementहरु सबै hide गर्छ. That's why it's called abstraction layer. Your type of cloud computing चाहिँ more native छ आजकल हैन, जुनसुकै cloud computing providerहरुले पनि provide गर्छ. But this is a different concept. You don't provision any services, you don't ask for what kind of servers you need. and it's gonna scale based on your use on that particular code you maintain. So यसले चाहिँ के फाइदा हुन्छ भन्दाखेरि स्केलिङको फाइदा त भइहाल्यो हैन, only use whenever user gonna hit on that particular piece of code, so you don't get charged for the whole infrastructure. जब कोडमा user gonna request it, then the resource will be used then, and then you're gonna pay for that. So if you look into the evolution of compute, यहाँ देखाएको जस्तै फर्स्टमा चाहिँ भर्चुअल मसिनहरुको कुरा गरे हामीले, IES, all those things, and then comes the containers. Containers के गर्ने भयो भन्दा, it's going to be more virtualized than the hardware level. It's going to virtualize the operating systems. And त्यसपछि चाहिँ अहिले functionsहरु आयो. Functions चाहिँ real time execute हुन्छ अनि it's going to reserve the resource based on the need, and you don't need to understand what is the underlying hardware being executed there. So अघिको एनालोगी हामीले जुन ट्रान्सपोर्टेसनको कुरा गर्दै थियौँ हैन, त्यसकै एनालोगीमा चाहिँ on premise भनेको getting a car your own, हैन, you're going to maintain, you're going to upgrade yourself, and you are on the full charge. Whereas IS भनेको चाहिँ like getting a car from a leasing office. So you go to the office, get the keys, sign some agreements, and once you are done, you're going to return it back. So त्यसलाई चाहिँ IS भयो हैन. त्यस्तै पास भनेको चाहिँ राइड सेयरिङहरु, जस्तो जति पनि हामी राइड सेयरिङहरु गर्छौं, we're going to share those rights for a particular duration with other users and then return it back. So that's pass. And SaaS भनेको चाहिँ calling a taxi service. So जब हामीलाई resource चाहिन्छ, whenever we need to go somewhere, we just call the taxi and then we go to the destination. So SaaS चाहिँ त्यो हो. And fast भनेको चाहिँ we can use any mode of transportation, not just a bus. You can use train, you can use boat or ship, anything you like. So you don't know, you just know the destination. You can use any type of transportation there, right? So that's a fast. So cloud computing ma yo duita term चाहिँ एकदमै important. So you need to understand virtualization. What is it? So virtualization हामीले अघि पनि एकछिन कुरा गर्यौं, containerization भन्दा अगाडि चाहिँ virtualization हुन्छ. त्यसको हिस्ट्री हेर्नु पर्दाखेरि चाहिँ virtualization मा चाहिँ what we're going to do is there is a hypervisor. Hypervisor layerले चाहिँ के गर्छ भन्दा यो चाहिँ म्यानेजर हो जसले चाहिँ the underlying host operating system लाई चाहिँ virtualize गर्छ, so that any new virtual machine can have their own guest operating system. So यो diagram मा देखा जस्तै you can have multiple VMs with their own separation. So एउटा VM ले अर्को VM को बारेमा थाहा हुँदैन, यसमा more secure हुन्छ, isolation हुन्छ. But the problem you can see is the resource use, right? And resource is going to cost you more. So use गरे पनि नगरे पनि whatever resource you asking for, that going to get you charged. अनि त्यो resource चाहिँ underutilized or overutilized भएको पनि हुन सक्छ. But on the other hand, the containerization revolutionized this, right? So what happens is instead of asking for the guest operating system from host operating system, now you don't need any guest operating system. So यसले चाहिँ operating system लाई नै virtualized गर्ने भयो. So के exampleहरु भन्नुपर्दा Docker engine, that's a new thing. There are other runtime engine also available to do this. So now the difference between these two diagram is first मा चाहिँ guest operating system हुन्थ्यो, अब second मा चाहिँ त्यो छैन. So containers are more lightweight. अनि operating system भन्ने बित्तिकै boot time धेरै लाग्छ. We'll see that at the demo as well. So boot time धेरै लाग्छ, but container are instances, like push गर्ने बित्तिकै एकैछिनमा build भइहाल्छ. अनि त्यसपछि resource utilization मा पनि फरक हुन्छ. Like we said, on the VM side, it's like overutilized, right? Underutilized. But on the case of containers, it's whatever you need, that resource is going to only be available for that containers. So there is always going to be lesser cost associated with the containers. And also deployment will be faster, and other benefits you can get from the containers. And सबैले भन्ने कुरा हो नि, just so when we talk about application, मेरो कम्प्युटरमा त चलेको थियो, but I don't know why तिम्रोमा चलेन भन्ने हुन्छ हैन. But containers will remove that kind of restriction. If it runs somewhere, then it will run everywhere. So portability को कुरा गर्दाखेरि it can run anywhere if you have a containers for your applications. So that's the main benefits of having containerization, right? And the cloud computing provides those services as well. We'll see that. So hypervisor को definition को कुरा गर्नु पर्दा hypervisor ले चाहिँ manage गर्छ all the resource, all the pools, all the VMs. So it's gonna create all the guest operating system in the VMs and then isolate them from each other. So more secure चाहिँ कुन हुने भयो भन्दाखेरि virtualized environment चाहिँ more secure हुने भयो. Container चाहिँ एउटै operating system share गर्ने भएर अलि lesser secure हुने भयो. That's the main difference. So I think this time it will work. Let's see. So can you go to this if you can? Your URL ma goi pani huncha menti.com ani 74628083. I just want to see your response. Or you can use your phone. Still the same problem? I think my Menti is. Let me check mine. Okay, it looks like I need to press C. Okay, I think now it's up. Can you guys try it again? Thanks. Yeah, I am new to Menti as well. Thank you. All right, so thanks for your response. So LSK देखाउँछ भने yeah, so the concept of cloud is whenever we talk about sharing and pulling the resource from the guest, the host operating system or host hardware, then that's a virtualization. So that's a answer for this. So virtualization is the one that makes enable cloud computing to come to this beneficial to everybody right now. I know. Okay. Thank you. Let's go move around. Right. And lots of things to cover. So yeah, if you guys have any question, let's take one or two questions if you have so far. China? Okay, good. So if you have any question, you can just use chat box ma chat send गरेर पनि हुन्छ. We can talk about that later on when we indicate our session. That's perfect. Okay, so now अब चाहिँ मेरो आफ्नै प्रोजेक्टको बारेमा अलिकति कुरा गर्छु हैन. So it's called New England Research Cloud, so also known as NERC. So this is a collaborative environment on-premise cloud computing setup that we have at Harvard. So it's shared resource. यो चाहिँ shared resource हो जसमा चाहिँ रिसर्चरहरूले आफ्नो cloud related workloadहरू request गर्न मिल्छ. Then they will get those resources and they continue their research among their team members. So यो चाहिँ हाम्रो Harvard, Boston University, MIT, other institutions under this region. New England भनेको चाहिँ यो Massachusetts regionलाई भन्छ. So त्यो regionमा भएको different universitiesहरूको collaborative effort हो यो हैन. त्यसमा MIT, Harvard, Boston University, Northeastern, UMass, the other institutions also part of this thing. So अघि हामीले जति पनि core servicesहरूको कुरा गर्यौं, NERC also offer those services. In the red box, you can see there's some virtual infrastructure, container, web application, databases को कुरा आउँछ हैन. त्यस्तै यसमा चाहिँ cloud engineersहरू हुन्छ, like me and others, system engineers who keep all the services up and running all the time. And there is a cloud facilitator. This role is also booming right now in academia. कस्तो हुँदैछ भने they have a researchers, students, or any other academic person. They don't have any advanced knowledge about technology. They have research problems. Or your cloud facilitator, they will translate those problems to the system engineers or cloud engineers so that they can be onboarded onto these services we offer. It can be cloud computing or traditional HPC setup, like high performance computing setup, but this role is getting a lot of attention right now in academia. So in future, तिमीहरूलाई पनि केही त्यस्तो टाइपको इन्ट्रेस्ट छ भने you can think about having this role. And you can move to cloud, like I did also. I was joined at Harvard as a senior cloud facilitator, and now I'm an engineer there. So that's just a career advice. And then NERC, underneath the NERC, there is a NESI. NESI भनेको चाहिँ North Exchange Storage Exchange होइन, Northeastern Storage Exchange. यो चाहिँ storage pool हो, यसमा चाहिँ धेरै टाइपको storageहरू पाउँछ. So we use a little bit pull from there to the NERC. So जति पनि virtual machine, जति पनि कन्टेनरहरू बिल्ड गर्छौँ त्यसमा चाहिँ यो पुलबाट के अमाउन्टको स्टोरेजहरू दिन्छ त्यो रिसर्चरहरूलाई. And then there is a MGHPCC, and the MGHPCC भनेको चाहिँ यो Massachusetts Green High Performance Computing Center. So यो चाहिँ data center हो होइन, जस्ट नाममै green छ भनेपछि this is obviously need to be carbon free, like carbon footprint free, energy consumption based on the renewable energy. त्यस्तो टाइपको छ. यसमा चाहिँ 100% renewable energy use हुन्छ, like water, wind, those kind of renewable energy use हुन्छ, न कि अर्को हाम्रो bio engineer energy. So that's why we use this as a data center, and all our hardware, all our data center is inside this MGHPCC. So NERC core services, अघि हामीले cloud computing core services को कुरा गर्यौं. So we also offer the similar kind of things. It's an on-premise cloud computing setup, just to let you know. So we have all those services. So we have virtual machine based on Red Hat OpenStack, where we provide user different type of CPU, GPU kind of resources. So यस्तो CPU, GPU चाहिँ अहिले क्लाउडमा पनि एकदम GPU चाहिँ public cloudमा पनि एकदम scarcity. So they will not get until some wait time. So if you ask for a GPU on the public cloud, you need to wait for some hours, some days, or even week. So that kind of resource we can provide. And container orchestration ko kura garda, we use Red Hat OpenShift. So they provide this containerized microservice-based workload handling. So we offer that. So underneath, I don't know if you know about Kubernetes. Kubernetes भनेको चाहिँ managing, orchestrating all these container workloads. So they are getting like a better and better every time nowadays. And we also offer this kind of service. And the software as a service मा चाहिँ हामीसँग Red Hat OpenShift AI छ, जसमा चाहिँ machine learning, AI or data science को workloadहरू गर्न सकिन्छ. So this is more dedicated platform as a service, okay? And then also we talk about NESI pool, so that acts as a storage as a service. So in the research को लागि persistent storage चाहिएको छ भने they can ask for some amount and they will be available to their workload. So persistent storage चाहिँ different type को हुन्छ, जस्तो it can be in terms of volumes or block storage, or if you want to use them as application based APIs, then you can use object storage. We'll see those demo later on. Okay, so not by numbers. There are 11 different institutions right now: MIT, Harvard, BU, Northeastern, UMass, there are others. And also we support some startups and other industry as well. And total users, 771. There are different students, academics, and other. And 67 PIs. PIs भनेको चाहिँ main research को lead गर्ने मान्छे. So there are total 67 PIs right now. And 121 unique projects. So you can think how much people can use if you provide some research on top, right? And 41 field of science. So you may have learned about computer science, but yeah, there are other science fields like life science, astrophysics, those kind of different kind of fields of science you can use in this kind of cloud computing. So here's a generic question. So I just want you to think about right now, but we're going to answer that using the ChatGPT kind of LLM later on. We'll ask this question to that model and get the answer from there. So the question is, how many cloud users are there right now in the world? So just think about it and just guess how many that can be, and just think about it. You can get that answer later on. Okay. Yeah, let me know if you guys have any questions so far. Right. So if you know, it can be billion or million. I don't know the answer, but we can ask that chat GPT later on. And कति भन्छ रहेछ हेरौँ. And sorry, Flavon. So wireless is related to cloud computing. Yes. So wireless, अहिले जति पनि टेलिकमहरू छ नि, टेलिकमहरू, they are using OpenStack, like that kind of on-premise data center kind of setup. So you can think of नेपालमा के छ, NTC, MCell, those kind of things are using their own private cloud. So because of those, how can we maintain control over our data in the cloud? So yeah, so the cloud is self-service, Rajiv. So के हुन्छ भने, you are in the full control of what kind of data you're going to put on cloud. And they provide the replication, disaster recovery, those kind of services on top of it. So even you lose from one point, you can get it back from another point. So you get a full control over it because you are, and you can manage as an organization, a whole team of organization can be managed on cloud. All right. Yes, sorry. Yeah, keep those questions coming so we can talk about general discussion later on. But I have lots of things to cover right now. All right, so next thing we'll talk about the demo. So this is going to be a little bit technical, but I'll try to as much as less technical as I can. तर यो टेक्निकल साइडमा चाहिँ के हुन्छ भने क्लाउडमा मेनली चाहिने स्किल सेट भनेको चाहिँ you need to know how to run a bash script. Bash script भनेको चाहिँ यस्तो टाइपको स्क्रिप्ट जसमा चाहिँ Linux based commandहरू हुन्छ. So you need to know those. That's it. Other than that, we are not talking about any programming language or anything. It's just a bash script and copy installing applications or packages, those kind of things. Okay. I hope that makes sense. So अब के गर्छौँ भने But I need to keep this side. So the first demo gonna be based on this. So I'll demonstrate हामीले चाहिँ infrastructure as a core, as a service कसरी use गर्न सकिन्छ हैन. यसको relevance चाहिँ हामी नटमै हेर्छौँ. नटमा चाहिँ Red Hat OpenStack use गरेको छ to use this kind of platform. And this is for virtual machines or dedicated instances. And I will show you how to get the cluster access and how we can set up our own VMs with CPU or GPU flavors. And also we'll talk about how can we set up a Jupyter notebook. Jupyter notebook यदि नयाँ हो भने चाहिँ यो चाहिँ web interface मै IDE हो के. So you can run any Python code or any R code on the web browser itself. So you don't need to set up anything in your local computer. It's all web-based development environment. And also we'll learn about how can we set up a remote desktop on that VM. We'll also talk about different types of storage, like a volume or block storage and object storage, and how can we interact with them using our CLI or the command line interface. So we'll talk about that. And also we'll try to set up our own chat model based on Llama 2 by Meta. Our generative AI को अहिले booming भइरहेछ हैन. You know there are different type of generative AI models. So you can see there are video generation, style transform, graph generative models, others. But यो Llama 2 चाहिँ text generation model हो. Chat GPT, GPT-3, GPT-4, those kind of new terms and new models also part of this text generation model. Okay, so we'll try to launch that and try to enter our prompt and see what the response is we're gonna get. All right, so I'll talk about this later on. Okay, so त्यसको लागि चाहिँ मलाई टर्मिनल चाहिने हुन्छ हैन. So this is the first demo that we're gonna do. अनि submit another. So how to get access to the OpenStack? So this is the OpenStack interface. You're saying publicly available, so now we are only allowing from specific institution. It's the onboarding process after, so I don't hope you're going to try it. But anyways, this will show you how can we use this kind of services in our life. Okay, so this is the interface of the OpenStack, the infrastructure as a service model that we talk about. So after logging, self-service. We can launch our instance, we can ask for how much we need for that instance, all those things we can do. So every project has a quota. Just the quota, we can launch up to 1,000 instance and 21 चाहिँ अगाडि नै मैले लन्च गरिसकेँ. त्यस्तै कोरको पनि आफ्नै कोटा हुन्छ, RAM, volume, storage, floating IP, those other terms. So they have their own quotas, how much you're going to get in this project and how much you are currently using it, right? त्यसपछि चाहिँ अब main काम चाहिँ हामी we're going to launch an instance. Launch instance is easy enough. So all I need to do is give a name. So नाम दिने हो, जस्तो llama2 setup गर्ने भएको भएर let's give it llama2. अनि operating system choose गर्नुपर्ने हुन्छ. जस्तो हरेक virtual machine or any instance or machine चल्नको लागि फर्स्टमा the operating system choose गर्नुपर्ने हो हैन. So we're going to choose Ubuntu based machine here. So there are different options we have here, like CentOS on the Arco, Scientific Linux. This we have Windows, Fedora. Those are different types of operating systems you can use based on your need. But for this demo, I'm going to use Ubuntu. Okay. So Ubuntu मा पनि अब मलाई यसमा मेरो LLM download गर्नुपर्ने भएको भएर I need more space. So I can specify, okay, give me 200 as a local disk within this VM. So it can be 200 or more based on your quota. And this was saying main कुरा चाहिँ यो flavor मा आउँछ. Flavor भनेको चाहिँ instance type हो हैन. यसले चाहिँ define गर्छ how much resource you're going to get on that VM. So for example, I can have different, they provide different kind of setups here. So if you are asking for a CPU, it's going to give you up to 1 core or 1 CPU and 4 GB RAM. And if you're asking for GPU, then there is a different options like, okay, give me NVIDIA A100 that has 24 core and 74 GB of RAM. And internally in our GB, internal GPU RAM पनि आफ्नै हुन्छ. जस्तो A100 को भित्र 40 GB RAM हुन्छ. त्यस्तै गरी A100 दुईटा A100 चाहियो भने यो फ्लेभर युज गर्नुपर्ने. You can think like having multiple GPU, how much research you can do on top, right? So दुईटा A100 चाहियो भने यो फ्लेभर युज गर्ने. अब मेरो LLM को llama2 चल्नको लागि चाहिँ at least P100 भन्ने GPU card चाहिन्छ. So I'm going to use that one instead of A100. All right. So let's select that. So how much we're going to get is defined here. So it says I'm going to get 48 core, 192 GB of RAM. Okay. So that is enough for running a llama2 model on any virtual machine. अर्को कुरा भनेको network. You don't need to care much about it because default network ले चाहिँ के दिन्छ भने यो VM चाहिँ बाहिर इन्टरनेटमा accessible हुने कि नहुने भन्ने सेटअप हुन्छ. त्यो by default we can select the default one. And security group is another important thing we need to select. Security कुनले कुरा गरेको थियो secure कसरी गर्ने भन्ने कुरा हैन. So you can secure your VM based on this port configuration. So firewall भन्ने सुने होला, same kind of concept हो हैन. जस्तो firewall मा पनि कुन port लाई कुन IP ले दिने access दिने नदिने भन्ने कुरा लेख्नु पर्ने हुन्छ. Same कुरा if you just get this interface. Interface le गर्ने काम पनि त्यस्तै हो. So you can say, okay, instead of publicly available गर्नु सट्टा only open port 22. यदि port 22 थाहा छैन भने port 22 चाहिँ SSH गर्नलाई दिने हो हैन. So let's do that. Also, we can access it over the internet with different ports, like port 80 भनेको HTTP, port 443 भनेको HTTPS. So we can browse this VM from the internet if we have some web server running on it. Okay. And त्यस्तै हामीले RDP भनेको चाहिँ remote desktop setup गर्नुपर्ने हो. जस्तो हाम्रो लोकलबाट डाइरेक्टली कनेक्ट गर्नु पर्यो भने RDP setup enable गर्नुपर्ने हुन्छ. So we can just open up that port as well. So all we did is open some ports using the security group, and key pair is also important. So this is my public key, and त्यसको private key चाहिँ यसले मलाई डाउनलोड गर्न अप्सन दिन्छ. So that private key is within my laptop, so I can connect to this VM using my private key because मेरो public key चाहिँ अहिले attach हुन्छ यो VM मा. So I can just SSH into this machine using my private key. Okay, and other options say your bash scripting, we're going to put it into this configuration. So what we are doing here, on that we are updating the VM, upgrading the kernel of this machine, and installing the NVIDIA driver. So even I mean, so NVIDIA card we cannot use that unless we install the driver. Driver let's kick install on that. All you require packages just CUDA भन्ने हुन्छ त्यो प्याकेजहरु इन्स्टल गर्दिन्छ. अनि त्यसपछि हामीले अरु पनि सानो एप्लिकेसनहरु प्याकेजहरु इन्स्टल गर्छौं जस्तो Python को भर्चुअल इन्भाइरोमेन्टहरु सेटअप गर्नको लागि. And after that it's going to reboot the whole system. Okay, so this is a simple thing we can do. Just ask or give a name, select the operating system with the size of storage that you need, and then select the flavor that defines the resource you're going to use on this. Security group opens the port or firewalls, and the key pair that is accessible in your local computer, the private key, and then some bash script. यो कुरा पछि इन्स्टल गरिसकेपछि SSH गरिसकेपछि पनि इन्स्टल गर्न हुन्छ, तर it's better to do it right now. So जब त्यो VM setup भइरहेको हुन्छ ब्याकग्राउन्डमा, this will try to set up on its own. Okay. All right, so that's all I did. We just changed 5 things and just launch it. So it will do the magic in the background and try to set up all those things. अघि हामीले virtualization र containerization को disadvantage को कुरा गर्दाखेरि virtualization is a part of this IaaS, right? So IaaS ma VM एउटा host operating system हुन्छ. Now we are trying to get a guest operating system based on Ubuntu on top. And boot time again, boot time is slow on this case, in this case, right? So you can see still boot it's going to take some time to boot. And if you try to see the log, you can see it's still not fully functional app. See, I cannot even access that VM right now. So that's why we talk about container gonna change this pattern, right? Container launch instance sales, like instant it's gonna be reflected on the VMs on the container side. So it's spawning up on the log funny of the so it's still gonna take some time. There drawbacks saying boot time there is a lightweight on the this is overuses of the resource. Use whatever resource you are selecting here, like a V100, that's gonna be charged based on your request. But यो भित्र चाहिँ हामीले प्रोग्राम चाहिँ त्यति धेरै युज गरेका छैन भने पनि you're going to get charged for this flavor. Okay, so that's the main drawback of having this kind of setup. Okay, so another thing is we need to access it using the floating IP. Floating IP भनेको चाहिँ public IP जसले चाहिँ हामीलाई access गर्न इन्टरनेटबाट access गर्न दिन्छ. So we're going to put that, and this is also controlled by the quota. If you're trying to get a new one, you can get it. But here I already have one requested, so I just pointed to that VM. Okay, so the floating IP भनेको चाहिँ public IP जसले गर्दा हामी SSH गर्न अनि इन्टरनेटमा एक्सेस गर्न allow गर्छ. अनि यो 192 चाहिँ सबै private IPs हरु हो, यो जति पनि VM ले हालेको छ. Okay, so this is building up, and by the time let's talk about column. So volume भनेको चाहिँ अघि हामीले स्टोरेजको टाइपहरु कुरा गर्यौं स्टोरेज दुई टाइपको छ यो IIS मा ओपन स्ट्याक मा So first thing is volume भनेको चाहिँ persistent storage हो block storage पनि भन्छ So now we can try to create a block storage let's call it a test volume अनि यसमा पनि कोटा हुन्छ जति हामीसँग प्रोजेक्टमा कोटा छ त्यो भन्दा बढी चाहिँ गर्न मिल्दैन So we're going to ask for 100 GB for now. Again, the operating system choose garda 200 GB use garate. So this is like a external storage for your VM that can be attached and detached to any VM anytime, right? So using just the hard disks or computer. So you can get a new hard disk with a large size of volume or storage and then just plug in into the computer and that storage can be used on your computer. Same thing, same concept of this model. Okay, so I can ask for more, but let's try with 100 GB. Using kun type of storage, block storage. So it can be only accessible through the VMs. जब हामीले यसलाई अट्याच गर्छौं VM मा तब मात्र एक्सेसिबल हुन्छ तर त्यसमा अर्को टाइपको पनि स्टोरेज छ जुन चाहिँ हामीले प्रोग्राममा एक्सेस गर्न मिल्छ using APIs we talk about that later okay so हामीले VM बनायो जसको साइज 100 GB छ so now I can attach this to the running VM right so the llama 2 is already running if you look into the log now log पनि अब appear गर्न थाल्छ see so now the logs are there अघि हामीले जति पनि bash स्क्रिप्टहरु लेखेको थियौ त्यो पनि बिस्तारै रन हुँदै जान्छ on the background so in the meantime हामीले चाहिँ त्यो VM मा अट्याच गर्न मिल्छ यो 100 GB okay so we're going to get 300 GB total in that VM right 200 GB चाहिँ हामीले VM launch गर्दाखेरि ask for the llama 2 setup गर्नको लागि 200 GB then after we extend it for another 100 GB by the volume okay so now let's try to SSS into that again हामीले port 22 open गरिसकेका छौं so we can just SSS भनेको चाहिँ त्यो VM भित्र छिर्न पर्यो हैन so how can we do that we can just SSS into that machine so let's do that SSS because हामीले ubuntu user ubuntu operating system user use गरेको भएर ubuntu user हुन्छ त्यसपछि floating IP चाहिँ public IP त्यसपछि we need to provide our private key so private key चाहिँ you just need to specify what is the location and the path right अनि public key चाहिँ हामीले अघि VM setup गर्दा नै attach गरिसकेको भएर it will recognize my private key so that's it so all we did is SSS that's a command and then floating IP with the username and then the private key path okay so now अब चाहिँ हामी त्यो VM को भित्र छौं यदि हामीले who am I भनेर सोध्यो भने अहिले चाहिँ हामी ubuntu user हो हैन but we can change it to the sudo user so अब हामीले who am I गर्यो भने it's a root user so being a root you can do anything on that VM right so you can install any application install any packages download or do anything on that VM so that's a benefit of having dedicated VM okay so that's a benefit and also we talk about let's talk about the storage again हामीले जुन 100 GB को storage attach गरेको थियौ त्यो कहाँ छ भन्ने कुरा हेरौँ हैन so we can do lsblk भन्ने कमान्ड हुन्छ so it will show you all the disk on that machine so you can see this 100 GB is the one that we just recently attached and this 200 GB is the internal local disk that we asked while we launching the VM okay अब disk मात्र भएर हुँदैन we need to format that disk too in order to use it right so disk matra format garnu parदाखेरि चाहिँ we need to format it with the file formatting so file formatting bhaneko jasto we may have heard about ntfs fat32 ext4 those kind of file formatting we need to use so you can use ext4 for this purpose okay so we are formatting that disk so that it will be usable and can be mounted in anywhere okay so if you do lsblk now you can see still it's not attached to anywhere so I mean attach चाहिँ कुनै एउटा directory अथवा folder मा गर्न सकिन्छ so त्यसको लागि चाहिँ एउटा test volume भन्ने create गरौँ mnt भन्ने directory मा त्यसपछि we can just mount that. Okay. So you can now mount गर्ने बित्तिकै if you do lsblk, then you can see the 100 GB चाहिँ अब यो directory-मा available छ भनेर देखाउँछ हैन. So if you go back and go to the mnt/test column, now you can get that 100 GB storage on that. Right now there is nothing, but you can हामीले चाहिँ के create गर्न सकिन्छ. जस्तो एउटा text create गरेँ, त्यसपछि if you look back, that will persistent over time. So benefit of having this kind of blocky storage चाहिँ कस्तो हुन्छ भने, so now you are done with your project, your research, you have your data on that volume. Now you can just detach this volume from that VM. Okay, so now अब हामीले काम सकिसकेपछि we can just detach it, and then that volume can be migrated or transferred to another VM as well. So detach गरेपछि अब if you go back to that machine and try to see what is the volume available, so that 100 GB our guy, so this is the benefit of having it. So you don't need to have every data within the same instance. You can have separate volume that can be managed and backed up regularly over time. And even you can do like a extend the size of this volume. Extend भनेको चाहिँ 100 GB थियो, अब मलाई 500 GB बनाउँछु. You can just ask for that, and then your total size of this volume will be 500 GB. Okay, so that's instantaneous. And you can also transfer this to another project. So एउटा प्रोजेक्टमा काम गर्दै थिएँ, मेरो रिसर्च अब अर्को प्रोजेक्ट छ जसमा चाहिँ मेरो अरु टिम मेम्बरहरु काम गर्दैछ, त्यसमा त्यो डेटा ट्रान्सफर गर्नुपर्ने भने you can just start the transfer, and from another project you can accept that transfer. And you can also create a backup, like a snapshot, so that you can recreate the whole VM from this volume later on. There are many options, many benefits of having volumes. Okay, so that's the one thing I want to show. And another thing we want to talk about is the object storage. So object storage difference चाहिँ के भयो भने volume चाहिँ attach गर्नै पर्ने भयो कुनै instance-मा अथवा VM-मा, but object storage चाहिँ पर्दैन. So you can just have a volume, just have a container like test container भनेको चाहिँ एउटा bucket भनेर सोचौँ हैन, and you can set up the permission for this bucket, like you can access it publicly or not. You can set up that. For example, I can say, okay, it is accessible publicly, and then I can just upload a file. Just upload a file, and now it's done. So if you go back to the link, you can see there is a file called GPU header. So यो चाहिँ अब सबैले एक्सेस गर्न मिल्छ, जस्तो यो अघि हामीले पब्लिक सेटअप गरे भएर whatever it is, even you can access it from the internet. Okay, so this is more helpful for like sharing data among different collaborators or researchers. जस्तो मसँग भएको आउटपुट, कुनै रिसर्चको आउटपुट or any research data or application चाहिँ यसरी publicly set गरेपछि you don't need to put a pen drive or hard drive or anything to share your data. Okay, user can just go to that and download it, or use other commands like call, duplicate भन्ने command or use गरेर आफ्नो local setup or local lab machine-मा download गर्न सक्छ. So this is one way, but I want to show you how can we access it using API. So त्यो चाहिँ main benefit हो नि त हैन programmerहरुको लागि, to use API to interact with the cloud computing setup that you have. So how can we do that? Let's do it. So first thing चाहिँ हामीसँग एउटा access credential भन्ने हुन्छ, त्यो चाहिँ हुनुपर्छ. यसमा चाहिँ मैले अघि नै सेटअप गरिसकेको छु. If you go back, so if you go back out from that machine, now I can do like app credential for that project. Okay, so if I do now OpenStack when a CLI command use गरेँ, container list गरेँ भने मेरो त्यो प्रोजेक्टमा जति पनि कन्टेनर छ त्यसको लिस्ट देखाउँछ जस्तो हामीले भर्खर टेस्ट भन्ने कन्टेनर अपलोड गरेको थियो नि फाइल यसले देखाउँछ so you can use this kind of APIs to interact with this same thing same web interface we saw there अब यदि लिस्ट मात्र गर्ने होइन कि we can even manage it we can delete it we can upload it we can do random things like that अनि अर्को so we have other APIs also, not just the OpenStack. So it calls Swift. So you can see the different CLI, you can interact with that, right? अब मैले चाहिँ यो OpenStack client र Swift client अगाडि नै set up गरिसकेँ local computer, so I can run those. If you do the Swift, you can see the same. So it will also list out any container that is available in my project. Like test is the container that is available. त्यसपछि अब यही command use गरेर let's upload one of the machine learning file that we have. यो चाहिँ हामी पछिको project डेमोमा use गर्छौँ. So यसमा चाहिँ यो cholesterol 3000 image भन्ने एउटा Onyx file छ. Onyx भनेको चाहिँ एउटा machine learning model file हो हैन यो चाहिँ हामी अब त्यो हाम्रो object storeमा upload गर्छौँ using this API. Okay, so let's do that. त्यो file चाहिँ मेरो local computerमा छ अहिले. So if you go back and you can see this cholesterol 3000 something into my, so it will upload it. If you go back to the same interface, अब हामीले त्यो अहिलेको object storeमा हेर्यौँ भने you're going to see a new object container will be created called OCP container, and it has that file that we just uploaded. Okay, so this is the benefit of having APIs. Now you can integrate this using Python code or any programming languages on your own. त्यसको लागि चाहिँ मेरो simple एउटा Python application छ. So if we try that, so यसमा चाहिँ मेरो त्यो bucketमा के छ भनेर list out गर्छु. So you can see when I run that Python code, it says I have this OCP container भन्ने bucket छ, त्यस्तै test भन्ने एउटा bucket छ, दुईटा bucket भयो. अनि OCP container भन्ने भित्र चाहिँ यो folder भित्र यो file छ भनेर देखाउँछ. So and त्यही हो त्यसमा चाहिँ Python codeले पनि अब हामीले interact गर्न मिल्ने हो. And you can do all the management things on top. All right, so that's having two different type of storage and how that can be helpful for any research and any project that we are working on. All right, so verify गर्नको लागि पनि command छ. So if you don't want to go and see on the browser, हामीले चाहिँ सिधै यही नै त्यो command run गरेर पनि verify गर्न सकिन्छ कि हाम्रो file चाहिँ त्यहाँ गयो भनेर. So if you try to run it, you can see मेरो OCP container भित्र Onyx भन्ने file upload गरेको छ. Okay, so this makes more helpful for the programmer rather than going into the web interface, doing all the stuff manually. You can do it from the program. Okay, so our हाम्रो त्यो instance को status हेरौँ है त. So we saw all the logs, and we can see still it's running because the driver and kernel updates gonna take so much time. Okay, so it will take some time. Okay, so before that, let's set up something on that VM as well. So Llama 2 को लागि चाहिँ हामीसँग यसभन्दा अगाडि चाहिँ हामीले कन्फर्म गर्नुपर्ने हुन्छ कि NVIDIA driver setup भयो कि भएन. So let's do that. All we need to do is अघि हामीले SSS जसरी गरेको थियो नि, so we can go back and SSS into that machine first. SSS गर्नलाई अघि मैले भने जस्तै you need to provide the username, the floating IP, and the path for your private key. That's it. I'm inside that machine now. अब हामी यसलाई CPU ले चाहिँ के दिन्छ भन्दा यसले चाहिँ CPU कति छ यो VM मा भन्ने कुरा देखाउँछ. जस्तो if you look into deep dive, you can see it has 48 core. that is CPU, virtual CPU. Okay, and this corresponds to हाम्रो जुन flavor use गरेको थियो नि त्यसको flavor को CPU पनि 48 AM. So this is corresponding whatever flavor you use, you're gonna get inside that machine. That's the thing. And if you go into the free MH, so यसले चाहिँ के देखाउँछ भने कति memory use भएको छ कति free छ भनेर देखाउँछ. So if you do that, you can see it has 188 GB of memory, but 187 is free. हामीले केही प्रोग्रामै चलाएको छैन, so it's all free right now. Right, and also we can check what kind of NVIDIA GPU card is attached. So you can see how the V100 use whatever, you can see it has Tesla V100 with 32 internal GB, 32 GB RAM available to this, right? So all the your internal GB चाहिँ के हो भन्दाखेरि जब हामी GPU based workload start गर्छौं नि, then it will use that internal GPU RAM. It will not use the 48 CPU RAM outside, right? So this is helpful. And if V100 मा 32 हुन्छ, A100 मा 40 हुन्छ, अहिले नयाँ आएको Vertex NVIDIA ले 1000 GB वाला पनि निकालिसकेको छ. So that's even gonna accelerate like all the GPU based workload on a single car. Okay, so if you look into this is okay, any अर्को command चाहिँ यो command NVIDIA SMI. This is important to see what kind of driver we have set up and what kind of CUDA. CUDA is a programming language like package that enable us to use the GPU card. So it has 12.2 version of CUDA. And केही अरु processor run भएको छ GPU मा भने you can see that here. Okay, so right now we don't have anything running, so we will see everything is ideal. And you can see also, yeah, 32 GB of internal GB RAM, 32 GB RAM available. All right, so let's build the Llama 2 model now. And to do that, a simple example. So हामीले SSS को त कुरा गर्यौं हैन, तर हामीलाई कति मान्छेहरुलाई चाहिँ SSS त्यो टर्मिनलहरु जान मन लाग्दैन नि हैन. So you can use this kind of SFTP terminals as well. Like this is a FileZilla based SFTP FTP server. So what you can do is just set up your floating IP with SFTP, and the username is Ubuntu, and I think the private key is in local setup ma jaन्छ त्यो. Once that you set up, then you can connect it, and you can see the same VM that is connected in your FileZilla setup here. So again, हामीले कहाँ गएको थियौं, MNT मा गएको थियौं हैन. MNT भित्र के थियो, टेस्ट भोल्युम भन्ने थियो, त्यो भित्र हेलो भन्ने थियो, तर हामीले त्यो के गर्यौं, अनमाउन्ट गरे भएर त्यो फाइल त्यही भोल्युम सँगै डिलिट भयो. But you can see the point, right? So you can connect now, you can just drag and drop your file from your local computer to that VM directly from here. So there are different ways you can interact with the volume or the VM itself. All right. So let's now talk about the Llama 2. So Llama 2, again, it's from Meta, Facebook. And these are some of the things we need to know before we jump into that. All right. So Llama चाहिँ open source LLM model. You can use it and download it. You can just request the source code of it. So you can just register it, and they will ask you some form to fill up, and then they will allow you to download the Llama 2. Our main LLM भनेको चाहिँ अब यो chat को लागि चाहिँ optimize भएको हुन्छ, fine tune or pre-trained गरेको मोडलहरु. And त्यसको चाहिँ different type of parameters हरु हुन्छ. Parameters भनेको चाहिँ if you look into the parameters, they have different options, right? Different parameter अनुसार different model बनाएको हुन्छ. So if you are thinking of like 7 billion parameters, then that's a 7B. 13 billion parameters used by 13B model, 70 billion. So जति parameter बढी भयो त्यति धेरै हामीलाई GPU-हरु चाहिने हुन्छ. So you cannot run 70 billion parameter model in one A100. You need like cluster of A100s. So GPU त्यही भएर एकदम expensive and एकदमै resource heavy हुन्छ. Right? So you need to think about that. And in this example, we're going to run 7 billion and 13 billion parameter model. So त्यही हो यसमा चाहिँ अब मेनली भनेको chat model हो. You can just interact with the model using a prompt and it will generate some response based on that model. Another thing is, so even though we talk about Llama 2, there are other ways we can get the Llama 2. Either हामीले त्यो मेटाबाटै पनि डाउनलोड गर्न मिल्ने भयो. So we can directly get the source code from the meta, or we can use another platform like Hugging Face. There is a company called Hugging Face. They provide this open source, more optimized for a particular use case. And those models are been already optimized, so you don't need to do any fine-tuning. Fine-tuning on any of the Tramo LLM. And you can see the token size for each of these pre-trained models, right? It's a 2 trillion. There are a lot. So if you're thinking of this to run on a simple CPU, it's not possible at all. Right? Okay, so त्यही भएर हामीलाई GPU भन्ने किन चाहिएको भन्ने कुरा. Okay. So Hugging Face को गर्दै थियौँ हामी. Llama 2 त मेटाको हो, तर Hugging Face ले चाहिँ के गर्छ भन्दा they provide us that fine-tuned Llama 2 models because they have a group of developers, researchers, all those team members. They always wants to optimize the open source model. So your Llama 2 चाहिँ मेटाको हो, but Hugging Face customize it, fine-tune it to do this dialogue-based use cases using Llama 2 HF. So you can use this instead of this. This is from Meta, this is from Llama 2. So similarly, there is a chat model specifically for the chat or dialogue use cases. So using Meta ko ho bhane yo chahi Hugging Face ko. So we're going to use the Hugging Face one, which is already fine-tuned and pre-trained. So we don't need to use the Meta-based LLM, Llama 2. Okay, so let's go so the thing we are trying to do is to run this generative AI using this Llama 2 LLM on the VM that we just set up using the GPU, the V100. And then also we try to set up some of the applications that allow us to run this thing on our browser. Okay, so त्यसको लागि चाहिँ हामीले Jupyter भन्ने युज गर्छौं भने अघि Jupyter भनेको चाहिँ इन्टरफेस यस्तो हुन्छ जसमा चाहिँ हामीले सबै कोडहरु एउटा सेलमा राख्न मिल्छ and individual सेलहरु एक्जिक्युट गर्न मिल्छ. But it's going to use the underlying hardware, all the GPU and CPU that we have on that top. All right. So त्यसको लागि हामीले अघिको त्यो VM मा चाहिँ Jupyter notebook, Jupyter setup गर्नुपर्ने हुन्छ. Yeah, so let's set up all this Hugging Face thing first. Okay, so Hugging Face को लागि पनि आफ्नै CLI हुन्छ. त्यही भएर त्यसमा त्यो सेटअप गर्नको लागि first we need to access it into that machine and then going to run all this command that we have here. So first thing, because we already the Python virtual environment setup गरिसकेका थियौं, application package install गरिसकेका थियौं, so we can just call okay, create a virtual environment for my work. And this was we need to activate that. So we're going to activate that virtual environment. And this was the pip install or some pip on a package manager. Just let's say I'm like जति पनि pip repository packages around, so we can just install using this pip command, like pip install, pip uninstall, those kind of things. Okay, so it will take some time. And this was we're going to install the Hugging Face, upgrade that, and then we're going to log in. So Hugging Face my important thing. So whenever we try to download the Hugging Face based model, we need to provide the token. So token भनेको चाहिँ मेरो account चाहिँ access गर्न मिल्छ मिल्दैन त्यो LLM भन्ने कुरा कन्फिगर गरेर आउँछ बिकज हगिङ फेसमा त्यो सोर्स कोड एक्सेस गर्न पनि वी निड टु रिक्वेस्ट सिमिलर टु लामा टु हामीले रिक्वेस्ट फर्म फिलअप गर्नुपर्छ देन दे विल एप्रुभ इट एन्ड देन योर एकाउन्ट विल बी एबल टु डाउनलोड देम अनि यो एक्सेस टोकनले चाहिँ मेरो एकाउन्टसँग त्यो एक्सेस छ कि छैन भनेर कन्फर्म गर्छ ओके सो द्याट्स वाट वी निड टु डु अन द्याट भिएम एज वेल त्यही बिचमा अर्को अर्को कुरा पनि हामीले इन्स्टल गर्नुपर्ने हुन्छ ल्याङचेन भन्ने हुन्छ ल्याङचेन चाहिँ के हो भन्दा यो चाहिँ प्रोग्रामिङ प्लेटफर्म हो फ्रेमवर्क जसले चाहिँ हामीलाई लार्ज ल्याङ्ग्वेज मोडलमा बेस भएर एप्लिकेसनहरू डिप्लोय गर्न मद्दत गर्छ यो चाहिँ पाइथन बेस्ड एप्लिकेसनहरू प्याकेजेसहरू हुन्छ होइन सो यु क्यान जस्ट कल द्याट इम्पोर्ट गर्न मिल्यो अनि त्यसपछि त्यसमा भएको अल फङ्सनहरू चाहिँ कल गर्न मिल्ने हुन्छ विल सी द्याट इन सर्ट टर्म okay so it's going to take some time because के गरिरहेछ भने हामीले अपग्रेड गर्यौँ हैन त्यसपछि यो सबै प्याकेजहरू इन्स्टल गर्दैछौँ यसमा टर्च भनेको एउटा जीपीयू को लागि हो त्यस्तै हगिङ फेस हब भनेको हगिङ फेसको लागि हो ट्रान्सफर्मर्स भनेको एलएलएम को लागि हो देयर आर डिफरेंट अदर प्याकेजेस आर also part of this okay so we talk about LangChain Jupyter notebook को पनि कुरा गर्यौँ so Jupyter हामीले यो चाहिँ एउटा यो त एकाडेमिक रिसर्चकै आउटकम हो हैन दे वान्ट टु डु समथिङ अन द ब्राउजर इटसेल्फ लोकल ब्यास कमान्ड अथवा टर्मिनलमा गर्नुभन्दा why cannot we do it on the browser so they create this Jupyter notebook kind of setup which we can do it on the web browser and यसमा धेरै कर्नलहरू पनि सेटअप गर्न मिल्छ जस्तो not just Python we can have R Studio R server or other different type of scientific कर्नलहरू पनि सेटअप गर्न मिल्छ and different add-ons extensionहरू enable गर्न मिल्छ and it can also do the visualization on top like interactive visualization so this is more popular in academia and also in the research field so I think this is one tool that everybody should learn how can we use it आजकल the Google Cloud को पनि collab भन्ने छ के अरे they are doing the same kind of thing all right so I think our applications packages I've done now we're going to set up our Hugging Face को लागि फेरि अपग्रेड गर्नुपर्ने हुन्छ then we're going to log in with the CLI and यो CLI login गर्दा अघि हामीले भने जस्तो हाम्रो access token चाहिँ प्रोवाइड गर्नुपर्ने हुन्छ so we're going to say no then it will allow me to log in from my VM to the Hugging Face so हामीले अब त्यो Hugging Face बाट मोडलहरू डाउनलोड गर्नलाई चाहिँ यो VM बाट सकिन्छ okay so we also talk about LangChain so we're going to install that also LangChain ले अघि हामीले भने अनुसार they're going to provide us the development platform where we can develop application on top of Llama too okay and त्यसपछि हामी Jupyter notebook install गर्छौं so everything is pip based pip भनेको अघि मैले भने it's a package manager on the Python so you can have different packages enabled or disabled based on that pip command अनि हामीले अघि virtual environment setup गरेको भएर it will be only scoped within that virtual environment okay okay so I think what we did is this one done yeah so again LangChain is done now we're going to install the Jupyter मा चाहिँ हामीले दुई अरु विजेटहरु पनि इन्स्टल गरेका छौं जसले गर्दा हामीले ब्राउजरमा हामीले त्यो पाइथनहरु रन गर्न मिल्छ okay so it will take some time by that time let's do set up a remote desktop things remote desktop चाहिँ किन चाहियो भन्दा हामी सधैँ यो bash मा गर्दा गर्दा वाक्क हुन्छ नि so we don't want to see this black screen all the time so we can do a remote desktop on top of this VM so for that we need to set up a password for the Ubuntu user अहिले चाहिँ Ubuntu को password छैन but now I'm going to set up a password for that and त्यसपछि XRDP भन्ने एउटा सर्भर हो यो चाहिँ लिनक्स को लागि हो हैन so we can set up XRDP यसले चाहिँ के गर्छ भन्दा remote desktop enable गरिदिन्छ त्यसपछि हामी we going to set up this virtual desktop environment called XFCE यसले चाहिँ हामीलाई त्यो डेस्कटप युज गरेर रिमोट डेस्कटप सेटअप गरिदिन्छ यसमा we need to enable that both, and then we can remote access that VM from our remote desktop client. I'll show that. Okay, so we can. Okay, so because one process is running, so we cannot do the another process on another terminal. Okay, so if you guys have any questions, any concern, let me know. We can talk about that questions later. Okay, so XRDP equalize and the Ubuntu ko username or password science they were on this set. First time we know the username, but we don't know the password, right? So PW password D and the username is secures on and the prompt query which asks us what password you want to put in that user. Okay, so let's see the time. Okay, so Llama 2. Do you have any questions right now? Or बाकी दुईटा डेमो चाहिँ अलि फास्ट रहेछ because they are just the demo to see it. This is to set up गर्नलाई चाहिँ अलि टाइम लाग्ने गर्दा अलि लामो छ. That's okay. So we're gonna end at 11, right? We still have 15 minutes. Okay, I can be done on that. All right, so let's do that. And we already did that XRDP setup. Now we're gonna do XFCE, that the desktop environment setup, and then enable XRDP license your desktop environment use one numbers. So your background magic key on that. It's trying to set up all these terminals. Terminals set up चाहिँ Ubuntu को kernel लाई update गर्नुपर्ने. And then after you need to add this thing as a secondary add-on. So that's why it's taking a little bit longer than normal application setup. Okay, I think we're done. All right, so we did that. Now we're gonna enable that environment that we just set up on this will restart also. I know restart this thing. Now we can connect to that VM using our own remote desktop. remote desktop भन्ने त देखायो होला जस्तो we have this. If you are a computer like a Windows machine based, then you can see this remote desktop. And here you can just set up like the username. Username चाहिँ Ubuntu हो हैन अनि Ubuntu मा now we're gonna see the password pop up. We can just especially we are inside that machine rather than going to SSS terminal. Now we can see it from the web, from the desktop itself. So I'm inside that machine right now. And if you try to do the same command that we run before, like NVIDIA command, you can do that. So we can run watch NVIDIA SMI. So it will do the like that command continuously. So whenever we run some program, that will also reflect it here. All right. त्योभन्दा अर्को चाहिँ we're gonna do yeah. So let's run that and do this two terminals open. एउटामा चाहिँ NVIDIA SMI call गर्छौँ अर्कोमा चाहिँ we're gonna see the Jupyter notebook running. So for that we're gonna run this Jupyter notebook run गर्नको लागि चाहिँ we can run in a specific project folder, right? And त्यसमा चाहिँ हामी we're gonna run our code from our local computer. So त्यसको लागि let's do it from this. So now we don't need anything from our bash terminal. Everything is connected over the remote desktop. यसको लागि चाहिँ मसँग डेमो भन्ने project छ त्यसमा दुईटा Python यो Jupyter notebook छ. So if you go back and go into that project and do ls, so you can see that demo is already uploaded and त्यो भित्र चाहिँ त्यो दुईटा files. Okay, so now let's run the Jupyter notebook. Jupyter notebook run गर्नको लागि चाहिँ all we need to do is Jupyter notebooks -- browser, and then after we need to go back to our local terminal because हामीले त्यो VM मा अहिलेसम्म port 8080 चाहिँ enable गरेको छैन. So we need to open that using SSH tunneling. Tunneling ले चाहिँ के गर्छ भन्दा अब instead of using localhost, instead of using the floating IP, now I can use localhost that connects to that particular VM. So यसमा token पनि enable गरेको हुन्छ. So we need to just open our browser using localhost. So if you do that, what it's doing is यो चाहिँ हाम्रो त्यो VM मा जे Jupyter run भइरहेछ नि, that is running in our local browser. Okay. So there are two files actually. So let's do it. 1 and 2. So again, हामीले discuss गर्यौं हामीले Hugging Face को chat model use गर्छौं 13B and 7 billion one, right? And the name is like -hf Hugging Face. So we can run this thing. And if you look back into the NVIDIA uses, कति drive use गर्यो भनेर, so you can see that again the processes will extend and then the GPU card uses will be reflected here on our VM. So त्यसको लागि एकछिन कुर्नुपर्छ किनभने first thing it will be start downloading the model from the Hugging Face using our token, and then it starts running our code which actually run the Llama 2 model. Okay, so it will take some time to reach through this point. So Jupyter notebook is यस्तो देखिन्छ हैन जसमा चाहिँ हामी हरेक सेलमा चाहिँ एउटा कोड हाल्नु पर्छ अनि हरेक एकैचोटी सबै सेलहरु एक्जिक्युट गर्नलाई चाहिँ यो प्ले बटन गर्ने यदि रिस्टार्ट बटन गर्ने यदि एउटा मात्र सेल एक्जिक्युट गर्न छ भने चाहिँ यो प्ले बटन गर्ने अथवा you can use your keyboard and control shift. You can use that way too. Okay, I think the idea is same. So you're gonna see the output later on, but let me complete other demo things. It's gonna take a little bit. Okay, so Llama 2 execute this, we're gonna see this one later on. So you can see the uses slowly getting up. So सो अर्को चाहिँ हामी डेमो चाहिँ ओपन सिफ्टको गर्छौँ होइन, जसले चाहिँ हामीलाई कन्टेनर अघि हामीले जुन बेनिफिट अफ ह्याभिङ अ भर्चुअलाइजेसन भर्सेस कन्टेनर भर्सेस भर्चुअलाइजेसनको कुरा गऱ्यौँ. सो वी क्यान सी हाउ क्यान वी युज a container rather than a dedicated VM that will use the resource properly and boot time पनि fast हुन्छ. So what are other benefits? We're going to see that. Okay. So before that, containers concept चाहिँ यो OpenShift भनेको चाहिँ कुबरनेटिस प्लेटफर्म हो, जसमा चाहिँ एउटा मात्र कन्टेनर होइन कि मल्टिपल कन्टेनरहरूलाई चाहिँ अर्केस्ट्रेट गर्ने काम गर्छ. अनि मल्टिपल कन्टेनर्सहरू चाहिँ एउटा पडमा राख्न मिल्छ. सो एभ्रिथिङ इज रिलेटेड टु पड. Pod has multiple containers, and those containers will be orchestrated by the Kubernetes. So that's the platform. So this is the interface. यो कस्तो देखिन्छ यस्तो देखिन्छ हैन. अनि यसमा चाहिँ अब एक्जिक्युट गर्नको लागि all we need to do is just import your GitHub. There are other ways to do it, but for now I just want to show you a simple example how it's easy. So simple node app छ जसमा चाहिँ मेरो इन्डेक्स पेज छ. इन्डेक्स पेजमा चाहिँ हेलो वर्ल्ड लेखेको छ. त्यसपछि त्यही प्रोजेक्टमा चाहिँ आई हेभ डकर फाइल. डकर अघि हामीले डकरको कुरा गऱ्यौँ अलिकता. यसले चाहिँ हरेक स्टेपमा के भन्छ भन्दा कहाँबाट के काम गर्ने भन्ने कुरा यहाँ देखाउँछ. जस्तो सुरुमा नोड भन्ने डकर रेजिस्ट्रीबाट डाउनलोड गर, त्यसपछि प्याकेजहरू इन्स्टल गर, अनि त्यसपछि ओपन दिस 3000 पोर्ट एन्ड रन माई नोड एप्लिकेसन. द्याट्स इट. So I just point to that GitHub repo, and also I'm going to open that 3000 port. That's it. So the benefit of यसको चाहिँ benefit के भयो, अघि हामीले VM setup गर्दा त्यत्रो टाइम लागेको थियो नि हैन. So it will not take that much of time. See, now it's already know what I need to do in order to run this application on this platform. अनि जति पनि हामीले चाहिने कुराहरू छ, it will know about it and just start deploying on the top. So this is platform as a service model. You don't know about the infrastructure, underlying infrastructure. You just use the infrastructure on top. And you can also see all the logs, what is going behind, and there are different ways to export it. Just the floating IP भन्ने कुरा गर्यो अघि हामीले. So similar concept container OpenShift मा चाहिँ route भन्ने हुन्छ. Route-ले चाहिँ अब हामीलाई publicly access गर्न दिन्छ त्यो application. Okay, so it's still building up, but it will not take that much time. So whenever it's build complete, now you can see it's already there, and you can see the output of that one. There's some issue on that. अर्को बेनिफिट चाहिँ अघि हामीले स्केलिङको कुरा गऱ्यौँ. जुन VMको केसमा चाहिँ we need to go back to the OpenStack, set up another VM, right? It's a hard scaling things. But here you can just click on this one up. So अघि हामी एउटा pod थियो, pod भित्र container थियो. Now you can have multiple pods at the real time. So now it's running 2 pods rather than 1. See, so your application will be more reliable, more resilient. So एउटा pod बिग्रे पनि it's gonna try to recreate another pod whenever there is something not running. यो भन्दा पनि अर्को interesting fact चाहिँ you can even do this automatically using this auto scaling group, right? So you can just ask for, okay, whenever मेरो एप्लिकेसनमा चाहिँ CPU utilization 80% thresholdमा पुग्यो भने अथवा मेमोरी 80 thresholdमा पुग्यो भने automatically create another pod, so that on demand it's going to support all those demand on CPU and memory utilization. So you can provide those maximum limit and minimum limit of pods, and it will do all those things automatically. So you know हामीले चाहिँ manually keep पनि गर्नु पर्दैन. Okay, so those are some of the benefits of having this. And for this example, I was trying to show you even we don't need to set up this thing manually, like launching the application there. So त्यसको लागि चाहिँ के छ भने एउटा simple CI/CD pipeline देखाउँछु है त. त्यसको लागि चाहिँ मेरो त्यो एप्लिकेसनमा चाहिँ अघि नै I set up a simple CI/CD pipeline. त्यो चाहिँ यहाँ हुन्छ. जस्तो वर्कफ्लो भन्नेमा OpenShift CI/CD pipeline हुन्छ. यसले चाहिँ के देखाउँछ भने what is the project I'm going to deploy this application, and कुन चाहिँ port open गर्ने हो, कुन चाहिँ registry मा deploy गर्ने हो, त्यो कुरा देखाउँछ। जस्तो यो चाहिँ मेरो यो registry मा गएर deploy हुन्छ। अनि त्यही कन्टेनरलाई चाहिँ build भइसकेपछि मेरो OpenShift मा चाहिँ deploy गर्छ all this step. Okay, so for that let's do a quick test. अनि त्यो सेक्रेटहरु अहिले जुन हामीले सेक्रेट अपलोड गर्ने त्यो चाहिँ यहाँ गएर बसिहाल्छ, जहाँ OpenStack GitHubकै सेक्रेट म्यानेजमेन्ट टुल हुन्छ एउटा, त्यसमा गएर मेरो OpenShiftको कन्फिगरेसन्स, टोकन and registryको पासवर्डहरु त्यहाँ गएर बसिहाल्छ। So nobody need to know about that. अनि हाम्रो त्यो अहिलेको जुन CI/CD pipeline file छ त्यसमा चाहिँ हामीले just call that name and the name of the secret. Okay, so that is more secure. Only you know what are those values. All right, so simple test गर्नु छ भने चाहिँ I can do it from the browser itself. के गर्न सकिन्छ भने ल अहिले नै अघि चाहिँ हाम्रो यहाँ हेर्दाखेरि के थियो आउटपुट, नर्क मात्र थियो, मैले डिलिट गरिहालेँ। But you can see now I change the code and do some comment and then commit it. So के हुन्छ भन्दाखेरि अब यसले गर्दा यसले ट्रिगर गर्छ GitHub action भन्ने। अनि whenever we have some change on our code, then it triggers those changes, right? अनि यसले चाहिँ CI/CD pipeline trigger गर्छ, जसले चाहिँ त्यहाँ लेखेको अघि हामीले त्यो OpenShift.yaml फाइलमा जति लेखेको छ त्यो कुरा एक्जिक्युट गर्छ। So it will try to connect to your Docker, build the Docker file, deploy it to your registry, किनभने registryमा मेरो username and password यसलाई थाहा छ। So it will try to deploy that on the registry and then connect to my OpenShift container. अनि त्यसमा गएर यसले build गर्छ and deploy गर्छ, and then we can see the output real time. So यस्तो टाइपको real time like collaboration अनि code testing, code deployment कामलाई चाहिँ OpenShift or any platform as a service model ले धेरै हेल्प गर्छ। अब यही काम हामीले VM मा गर्नु पर्यो भए you need to set up all these things manually. Even VM मा पनि we can set up this kind of CI/CD, but still this is more cloud native. Okay, so let's wait until it's complete, and let's see our Llama 2 what's going on with that. So Llama 2 को लागि हामीले VM setup गरेको थियौं, and if you look into it, you can see now त्यो अघि 32 GB RAM थियो नि, internal GB RAM for the GPU. Now it's using portion of it because we run the Llama 2. And Llama 2 को output पनि आइसक्यो। So yeah, so this is the one we just run, and you can see it asking some questions like how can I learn about cloud computing, and using this Llama 2 it asks response back this kind of answers. So you have seen the ChatGPT the so you can build your own like this. It's just a Jupyter notebook, but you can build it as an interface and then build an application on top of it. So our previous question के थियो, how many so let's ask the same question that we tried to answer. त्यो चाहिँ हामी 13B मा सोध्छौं है त। If you can answer how okay, so we can ask that for the 13B. So the benefit चाहिँ के हुन्छ भने 13 billion parameters चाहिँ more precise हुन्छ, जबकि 7 billion चाहिँ अलिक कम precise हुन्छ, त्यही भएर resource पनि धेरै चाहिन्छ हैन। So we can change the code and then, or we can just ask it there rather than here. Okay, let's ask it. So we don't need to download whole model again. We can just change the prompt and then execute that cell, or you might want that. You can just click on this play button or just Control Shift and Enter. So it will take that answer, take that question and then generate the answer for that. Okay. So त्यो हेर्दै गरौँ। त्यसपछि हाम्रो CI/CD pipeline चाहिँ अब it's completed. So you can see it's a green and everything is deployed. And you can see it's been deployed to the OpenShift cluster. And you can see the outcome of this. So here's the main website that is generated out of it. So you can see whatever मैले त्यो गिटहबमा जे चेन्ज गराएको थिएँ आउटकम चाहिँ यसमा आयो हैन अनि त्यसको डिप्लोयमेन्ट चाहिँ यसमा हुन्छ you don't need to say it but yeah you can see what is the status of your pod or the container on your real OpenShift. So this is the one that is deployed by this CI/CD pipeline. Okay, so this is interesting thing that we can do. All right, I'm gonna slide this. Give me a second. I think my slide is stopped or something. All right. So yeah, I think that will conclude my two demos. I don't know, we have time for a third one. But I can really quick show you guys that. All right. So the third one, say we're gonna show you about the machine learning things. Okay. So we talk about OpenShift. There is a plugin called OpenShift AI or data science platform. And this magic you can just see the workbenches. So you have a project. Now we can see different workbenches for that particular project. Now we can create our own workbench. Oh yeah, and the Jupyter Zoom setup using the VM. Or you can answer 20 hours. How many cloud computing are there? So yeah, this will get improved over time. And if you use more like 13B or 40B, those kind of large parameterized model, then it will get more accurate. Okay. All right. So Red Hat OpenShift AI. So what we can do here is यहाँ चाहिँ हामीले आफ्नै workbench setup गर्नुपर्छ. And this can be shared among not just one person or group of team members you can share with. And यहाँ चाहिँ धेरै टाइपको इमेजेसहरू पाइन्छ जस्तो you can use GPU based TensorFlow, CUDAs, Python, simple data science platform, those kind of things can be easily integrated. And here, based on your workload, you can ask for the size of your container. Container भनेको चाहिँ यसमा pod हो हैन. So you can see like 2 core 8 GB or more, you can ask those kind of resources for that. And you can even ask for GPU. So you can ask for, okay, give me 4 GPU integrated within same container or 1-to-1. Okay, so that's what we can do here. And persistent storage, again, the storage ko pura garyo jati pani. So you can get those storage, same benefit. You can have all your data, all your program store on this persistent storage. So you can create that. For example, I have already created one. So this is the one I have. So here what we have is TensorFlow. I have 1 GPU, small size container, and have a persistent storage of 1 GB. Okay, so once that is ready, now you can just click on open and Jupyter Notebook open also. यसलाई चाहिँ Jupyter Lab भन्छ. Jupyter Lab environment चाहिँ अघिको Jupyter चाहिँ single page भयो हैन. यसमा चाहिँ you can just integrate your whole workflows here. So यहाँ चाहिँ अब हामीले you can just upload your own GitHub repo. For example, if I want to upload a new one, I can just upload it from my GitHub. So you can see I have this repo from so this is the one that we are trying to see. So yay repo, we just copy it. We don't need to copy paste here. You can just import it using this tool. They already integrate the GitHub on your workbench. Okay, so just integrating that, it will ask for all these things and get it all in your own workflows here. So यहाँ चाहिँ के छ भन्दा फर्स्टमा चाहिँ let's see, because I asked a GPU, right? So GPU चाहिँ छ कि छैन त यो Jupyter नोटबुकमा युज गर्न मिल्छ कि मिल्दैन थियो. So हामीले अघि workbench setup गर्दा we ask for 1, so you can see it has 1 GB one GPU available, and you can see it is based on A100. Or example, B100 here, obviously A100, and it has 40 GB of internal GB RAM. Okay, and you can run other Python code as well, some visualization tools based on your data, and also you can run some interactive visualization widget also on Jupyter notebooks. All right, that's a basic Jupyter things. What we are trying to do is that. Let's see the machine learning part, right? So we know it has a GPU. It's a high-end GPU card attached to the Jupyter notebook. Now I can try to train my model. So use simple example, TensorFlow use we are trying to train this model using some public data set from Pearson MNIST datasets. So all you need to do is just execute this Jupyter notebook, and it will train all the model for you and generate the model file for your workflow. So this is doing well, and then we can do the remote inferencing. Okay. So त्यसको लागि चाहिँ के गर्नुपर्छ भन्दा we need to serve our model first. So model serve गर्नको लागि we need to create the model server first. Model server, you can just give a name, select the runtime. Open Reno भनेको चाहिँ IBM ले create गरेको image detection model server. You can use either CPU based or the GPU based, and you can also ask for replication. How many कतिवटा server run गर्ने and कुन type of resource you want to use on this server. So you can define that, and also if you want to use GPU or not, you can define that things too. So in this example, what I did is I didn't ask for GPU. I just asked for the CPU-based model server, and then asking only one replica with a small size. Okay, so model server ready भइसकेपछि now we can start deploying our model. So for deploying, we just need to give a name. Then we need to select the Onyx file that we store on our OpenStack before, right? The object storage मा जुन हामीले file store गरेको थियो नि त्यसको नाम दिने अनि त्यसको लोकेसन दिने. अहिलेको लोकेसन चाहिँ कुन हो भन्दा यो open OCP container भित्र cold store model भन्ने थियो. If you remember still that. So त्यो चाहिँ कहाँ थियो भन्दा त्यो चाहिँ हाम्रो OpenStack को object storage को OCP container भित्रको cool store model भन्ने folder भित्र. So we define those external data connection here and the folder name, हैन? त्यो भएपछि यसले थाहा हुन्छ कि यो भित्र Onyx भन्ने एउटा format को model file छ. And now that once that is deployed, यसले deploy गर्ने बित्तिकै के हुन्छ भन्दा it will generate some endpoints. Machine learning को term मा भन्दा inference endpoint भन्छ. And त्यसले different type of endpointहरू generate गर्छ. जस्तो RESTful APIs or gRPC URL endpoint. gRPC चाहिँ अहिलेको नयाँ API configuration protocol हो. So this is more reliable than using the REST or URL REST. Okay. So we're going to use this, and let's see हाम्रो Jupyter notebook मा we're going to copy that here, right? And we're going to execute this whole thing. So execute गरिसकेपछि के हुन्छ भन्दा what we are trying to do here is we are trying to find out what are these objects. जस्तै यसमा t-shirt, cap, hat, bottle छ नि. So we are trying to use that model that we created and then run some Python code to predict what are those objects. So यसले त्यो run गर्दाखेरि हाम्रो based on a model, it predicts this is shirt, this is hat, bottle, with some confidence level, like 64% say your model assures this is a shirt and this is a hat, 88%, 86% it's a bottle. So you can see this kind of tools and machine learning platform we can do within our web browser or the Jupyter notebook setup on the workbenches. So that's the benefit of having this software as a service model on top of it. And even you can deploy this as an application, real application. So how can we do that? Is go back to your containers and then add this YAML file. So त्यसको लागि चाहिँ हामीसँग दुईटा YAML फाइल छ. One is called front end ले चाहिँ त्यो camera देखाउँछ. The second one is the inference that connect with our inference endpoint that we just created. Okay. So what we're gonna see is it's gonna create those two pod that has that container and that has connection to the inference as well as it has the front end. So this kind of intelligent application can be created using this roles, right? Internally, we are using these internal services, whatever we serve on that model server. And at the end, it's gonna look like this. So it will pop up this window where we can, by the Zoom I cannot use that video, but you can show it on the camera and it will detect your object on the camera itself. So that's the overall demos, I think. Yeah, so this is what it's gonna look like at the end. If you show a camera, your camera, the bottle, it's gonna predict it's a bottle and how much confidence in it. Okay, so I think that's conclude my demo and all the session. Okay. Yeah, if you got time, you can do it, but let's take some questions if you guys have any questions. We can either do pressing. What is one? Yeah, so you can give your input in it and let me take some questions if you guys have any. Yeah, Salin, so career advice it up to yours. Nowadays, cloud computing, like you saw, the demand is so much. अनि एकाडेमीमा त झनै कम रिसोर्स छ, इन्डस्ट्रीमा पनि त्यस्तै छ. So I think you should start learning the basic. You saw हामीले देख्यो नि, Linux is the must. You need to learn Linux thing, the bash script, how can you learn? And then you can start doing some administrative side, like managing applications, going to the logs, seeing the log, what it is saying. And basic चाहिँ कुरा गर्यो आज लगहरू पनि हेर्ने, तर what actually those logs is talking about, those kind of things is also part of cloud computing. System administrations, cloud engineers, those people work on that more focused, so that your whole cloud setup up and running house. So there are many avenues you can explore. It's not just the application development you can focus. You can do system level support. You can do machine learning. We saw some of the cool tools they are using. And research is another thing too. Okay, so cloud facilitator को काम चाहिँ के हो भने, so like I mentioned, academia professor, the PI they don't have that much technical background. So some of them are from like biology department, so they don't know about computer. They think computer can do anything. तर त्यसको they're like research problems. They are doing research for 40-50 years. They have lots of data, lots of outcomes. So cloud facilitator can help them to translate those research problem and then recommend them what kind of tools on the cloud side they can use using cloud facilitator, because they act as a mediator between the actual technology and the research. MLS does everything from fine-tuning. Yeah, I think that ideal term creating the model itself is another big market, right? So हामीले चाहिँ अहिले chat model हेर्यौं, त्यो चाहिँ कुनै कसैले बनाइदिएको model हो नि त. But if you're thinking of like real use case, you need to train them with your real data. So just there is a Bloomberg भन्ने पत्रिकाले So they did the machine learning for their own purpose on their own newspaper data set. So they can ask for a particular data set related questions. And you can think of the same way, like in research. हामीसँग एउटा research problem थियो जस्तो, let me show you quick what was it. Yeah, there are many use cases I forgot to put, but time पनि भएन. So this is one of the interesting project that was running on Merck. So they have a whole genome sequence data that is more around 32 terabyte, and they are developing different tools on top. अब त्यसमा LLM कसरी युज गर्न सकिन्छ, machine learning. अब उनीहरूको आफ्नै त्यत्रो data set, so they don't need external data source. If they can use the LLM on top of this 32 terabyte of data source, that will be more helpful, more like useful for their own community, right? And your community, our human genome sequencing community ठुलो छ. So that can be only tailored for that particular group, scientific group. And you can think of 8 billion of total variants out there. So yeah, there are specific like machine learning engineers, MLOps, you can help them with the workflows, or you can set up and create their own LLM models as well. Mukesh has some question. How can we maintain control over data? Yeah. Okay, so you talk about some of those questions, right? Privacy ko kura garda agi hamle kura garyo ni. Security groups, those firewalls, those kind of setups, you need to do yourself, होइन? जबकि सेल्फ सर्भिस भन्ने कुरा त्यही भएर आउँछ. अनि रेस्पोन्सिबिलिटी भन्ने कुरा पनि हुन्छ क्लाउड कम्प्युटिङमा. जस्तो AWS को रेस्पोन्सिबिलिटी मोडल चाहिँ सेयर्ड रेस्पोन्सिबिलिटी मोडल हुन्छ. हार्डवेयर अथवा एनी एप्लिकेसन सर्भिस लेभल चाहिँ AWS ले गर्छ भने जुन होस्ट गर्ने कामहरू छ, जति पनि एप्लिकेसनहरू छ, त्यो चाहिँ युजरको रेस्पोन्सिबिलिटीमा आउँछ. So it's up to users how they gonna manage. अनि त्यस्तै डेटा प्राइभेसीको कुरा गर्दाखेरि different countries, different research has their own guidelines. They were AWS भन्ने बित्तिकै public cloud मात्र हुँदैन. They have their own version of like government data राख्ने आफ्नै data type को services हुन्छ. त्यस्तै रिसर्चमा पनि HIPAA यो जति medical recordहरू राख्ने हुन्छ. They provide their own secure infrastructure for that. HIPAA compliant भन्ने हुन्छ. So it's up to us what kind of data we are trying to store, and then we can choose those services on top. Yeah. GPT-3, yeah, OpenAI, they store those. They are the news सुनेको छैन. So people are, OpenAI is trying to invest on the infrastructure rather than just the development only. You know? They saw the potential, and now they are asking for कति trillion को, I forget the news, but अनि cost को कुरा गर्दाखेरि, yeah, we are thinking like ChatGPT is so easy, but they are spinning up so much cost in the background. They were the model or asanda, so you need to pay in order to use the GPT-3 or GPT-4, but you can do the basic search using the simple one without paying. But internally, they are paying so much on the. They were their data center green अथवा eco-friendly concept as an, so you are not wasting it and hampering the environment, because data center is huge. If you think होइन जति पनि हार्डवेयर हुन्छ त्यसमा कुलिङ सिस्टम सधैँ त्यो AC चलिराख्नु पर्ने हुन्छ. There's so much energy waste there. Yeah, AWS is not free. But I think AWS-मा पनि कुनै सर्भिसहरू चाहिँ नेपालको कन्सेप्ट थाहा भएन, but I think they need to put some credit card. Yeah, that's the first point they need to subscribe. Okay, I think that's a good idea. Okay, any co-host or like interesting question, Vidya? I can answer those otherwise. Yeah, I think at the end we can connect. I'll be more than happy to give you any guidelines, any suggestion I have. Made a website, so you can find me there. My LinkedIn, my maybe not Facebook, maybe Twitter. We can connect. Yeah. So to I think all we need to know is how can we start the cloud journey, right? That's the main question. So my cloud there, college my CKO. Then after I try to learn more and doing practice. You need to practice more. Like how can I improve over time? अनि सिक्न पनि त्यति सजिलो छैन because you saw the services like 300, 200 services. Which one you begin, right? So that's a quite challenging part there. But you can start from the basic, like learning about cloud, learning the set of the VMs, and then you can go to the container and other stuff. And you can get different kind of roles. So you can see roles like cloud architects, system engineers, system administrators, or DevOps engineers, or DevOps administrators, MLOps. You can get different roles, and you can see the future here, like not just the cloud computing. You can uh, think of machine learning, uh, data security, quantum computing, blockchain. All these things are coming out. And cloud also has this Kubernetes. We saw the OpenShift, but AWS has their own Kubernetes things too. Yeah, either VRAM. Yeah, I think the Google Cloud, Google Colab gives you some free credits. Oh my God, what are the most paid jobs? Now, because everybody is trying to Gen AI, so I would suggest to go toward that part to get more paid on US or any other global market, right? I think the hype also boston because still we haven't seen the real use cases of Gen AI or LLM. So it'll take some time. So try to pursue that, and maybe you're gonna get a job that has a higher value. Katie, come back. When? Sorry if he's looking for some cardless payment. Support your cardless payment. Yeah, I have no idea. Like ATM machine also connected to the cloud, but कसरी त्यो maybe they have some internal issues there. Okay, so I think that's cover up most of the thing that I tried to. Yeah, there are other use cases we didn't talk, but people are doing random things. One interesting project I can show you is because of Nepal is also the earthquake. I had chance to talk with this professor and also discuss about that. So using GPU-based workload, what they are trying to do is simulate the whole earthquake on the GPU model. So what they are trying to do is whenever the earthquake happens, होइन जब हुन्छ नि त्यतिखेर त्यो दुईटा सर्फेस बिचमा हुने त्यो रप्चरलाई प्रेडिक्ट गर्न खोज्दैछ अनि कसरी मिनिमाइज गर्ने भनेर उनीहरूको साइन्टिफिक रिसर्च हुन्छ दे generate so much data out of it and they need so much compute power to do this kind of simulations. Other than that, there is simple web server applications that can easily be run. Or you might want a whole genome sequencing data set. That's a huge contribution to genomic community to understand about disease, all about human body, right? Yeah. And this is more like GIS, another field. They want to use machine learning on the GIS data set. This is also interesting to see. So जति पनि sentiment analysis हुन्छ जति पनि geotag tweetsहरू हुन्छ, they want to narrow down the search on a particular geographic locations on a given time. And they will try to see what is the sentiment of that particular topic and the particular group. यसको main benefit चाहिँ, I think they put that, right? On a given time, like a COVID change or climate change, so impact कसरी परिरहेछ मान्छेमा on a particular time, on a particular locations, those kind of things. All right, I think that's fine.